Hi, I'm Andy, and this is my lesson on binary search in Java. In this lesson, I'll show you how to write a recursive binary search method that can be used to search a sorted integer array. Let's get started. In general, to search for a number in an integer array, you need to use a blunt force algorithm, which simply examines each array element one at a time until the desired number is found. This type of searching algorithm is called sequential search or linear search. It's simple and straightforward to implement. You just write a simple while or for loop to traverse the array, but it isn't very interesting. However, when you're faced with a sorted array, an array in which the elements are arranged from smallest to largest, you can employ a much more efficient and interesting search algorithm called the binary search algorithm. Before writing any code, let's see how it'll work by working through a specific example. Suppose this is our sorted array, and we want to know the array index that contains the number 26. The first thing we should do is check our target number against the middle number, this one right here. Since our target number is bigger than that middle number, we can split our array into two parts, and then focus our search efforts on just this part. This is why we call it a binary search algorithm. Binary essentially means composed of two things, and this algorithm treats the array as being composed of two smaller arrays. Now we basically want to do our search algorithm again, this time on just this highlighted portion of the original array. So it looks like our method will be a recursive method, because to complete its task, it will call itself, this time on a smaller subset of the original array. So again, we find the middle number and compare it to the target. This time the target is smaller than the middle number, so we split the search area into two smaller subarrays and call our search method on this part. Now we find the middle number again. Since we only have two elements in our subarray, either one can serve as our middle. Our algorithm will choose this one. Now the target number and the middle number are equal. That means our search is done. We found the target. At this point, the method would end and return the index 6. Notice the efficiency of this method compared to a sequential search. During a sequential search, your program traverses the array one number at a time until the target is found. The search area reduces by just one element each time your number isn't found by the algorithm. During a binary search, the search area gets cut in half each time your number isn't found. When dealing with a small array like this one, this difference doesn't matter much. Both algorithms will take hardly any time at all to complete the searching task. But when you have a large array, this difference is huge. A sequential search will, on average, take much longer to complete. Because of this dramatic improvement in efficiency, you should always use a binary search algorithm when searching a sorted array. Okay, now let's write the code for this algorithm. As we just saw, the binary search method returns an integer, the index containing the desired number. It also contains several parameters, one being the array of numbers we want to search, and another being the target number our method is trying to locate. Also, remember that while searching, this algorithm is repeatedly cutting the search area in half. That means we also need some parameters to mark the start and end of the array's search area. Let's call those start index and end index. Now for the method body. Let's start with our base cases, the conditions that end the recursive method. In this method, there are two base cases. The first base case is when the number is found. To check for that base case, we first need to get the middle number. The middle number's index can be found by averaging start index and end index. In our example, when we first call this method, start index will be 0 and end index will be 10. So middle index will be 0 plus 10 divided by 2, which is 5. And you can see that 5 is indeed the middle index here. Now we can get the number at that middle index and check to see if it equals our target number. If so, we're done. We found the target's location and can end the method by returning that index. So that's our first base case. When this condition is encountered, the method ends. The second base case is when we know for sure that the number we're looking for is not contained anywhere within the array. To see when that condition is met, let's think about what would happen if we search this array for the number 11, a number which is clearly not anywhere in our array. Remember, as our algorithm searches for the target number, the search area shrinks, meaning start index and end index get closer and closer together. Eventually, if the target isn't found, the end index will end up to the left of start index, like this in the case of a target of 11. It is at this moment that we know for sure that the target num is not in the array. So that's our other base case. No matter what, this method must return an integer. So we need to return an integer here that somehow indicates the target number wasn't found. Since -1 is never a valid array index, we can use it to indicate this condition. This is also a good choice because other Java methods, like strings index of method, use -1 in exactly the same manner. So this is a somewhat standard Java convention we're using. Now let's deal with the non-base cases. To see how that works, let's assume we're in the midst of our first call to the binary search method. That means this is the start index, this is the end index, and this is the middle index. First, let's check to see if the target number is less than the middle number. If so, we need to call the binary search method again, this time on the left half of the array. To do that, we keep the start index the same, but reduce end index to the middle index -1. Otherwise, we call the binary search method on the right half of the array. We do that by changing start index to middle index +1 and leaving end index the same. And that's it. That's our recursive binary search method. Let's test it out for a number that's in the array and one that isn't. Good, everything worked. Again, don't forget that this binary search algorithm can only be used when dealing with sorted data. If the data is not fully sorted, this algorithm simply doesn't work, and you must use some sort of sequential searching algorithm. And that wraps up this lesson on binary search in Java. I'm Andy. Thanks for watching and coding with me today.